Hey guys, happy Thursday. It's almost a long weekend. So I'm putting together this video. I don't want it to be too long to take up too much of your time, but I've received a few emails from people asking about today's Socrative and adding or subtracting to eliminate a variable in order to solve a system of equations. So first of all, I just want to say thank you so much for emailing. It shows me that you're super invested in what you're doing and that you're willing to kind of take that extra step to figure out what the right answer is. And to be honest, I would love to help out in any way that I can. So always ask questions if they come up, and if you don't want to wait until the Zoom check-ins to speak up, you can always ask questions ahead of time. And this is probably something I'll go over again on Monday, but I know some people are looking for clarification right now. So thank you so much for that. Okay, so before I've added two examples from the Socrative to this that I'm actually going to do with you. But before we even do that, one of the questions I received was, how do we know if we should add or subtract? And so one thing we know when we're going to solve a system is that our goal based on elimination, right? Elimination means to cancel out. And we were told ahead of time that in order to do that, we're either going to add or subtract. And the reason that's the case is because addition and subtraction are the operations that can really get us back to zero. And so I created 4 math problems here. And so this says 5 blank negative 5, negative 2 blank 2, 4 blank 4, and negative 3 blank negative 3. And so what I want to think about what these blue directions say, it says in each red square, place either addition or subtraction in order to get an answer of 0. So for every single one of these problems, I have 2 options. This could either say 5 plus negative 5, or it could say 5 minus negative 5. And I know I want the answer to be 0. So let's think about that for a second. Should this say 5 plus negative 5, and would that equal 0, or would 5 minus negative 5 equal 0? And so if you're thinking that it should be plus, you'd be right, because 5 plus negative 5 is 0. So in this case, addition is the thing that would cause this to eliminate. Now in a second, we're going to do this with variables, but this is kind of going to be our thought process. So let's jump ahead to this one right here. What about 4 blank 4? And I want the answer to be 0. Should it say 4 plus 4? Or should it say 4 minus 4? What would you put in that box? If you're thinking you would put a minus, you would be right, because 4 minus 4 is 0. Pause the video for a quick second, and I want you to do these two out loud. And again, you want the answer to be 0. And if you talk to yourself, I promise it's going to help. Say it out loud. And don't worry, you're not in school, so no one can hear you. And then when you're ready to check your answers, press play. Okay, so the first one that I gave you, negative 2 blank 2. So negative 2 plus negative 2 plus 2, that's going to be 0. Because remember, if I'm doing a negative plus the positive, I keep the sign of the bigger number. Well, neither one's bigger. And I subtract, but 2 minus 2 is 0. So that would be a plus. And then on this one, negative 3 minus negative 3 would be 0. Now, if you accidentally put plus, think about that. What that would say is, it would say negative 3 plus negative 3, which would actually be negative 6, right? But if I leave it as negative 3 minus negative 3, well, now I'm minusing a negative, which means I get to do keep, change, opposite, and now negative 3 plus negative 3 is 0. Okay, so now I'm going to use that background knowledge just to help guide me into figuring out what operation should I use to eliminate. And so let me just use a different color here for a second. So I'm going to draw a red line. I'm going to put a circle. I only put the circle just because it kind of draws my attention to it. And so I know right now my only 2 options in this circle are to either put a plus or to put a minus. But I think the first question people have is, well, how do I decide which of those 2 things to put? Unfortunately, it's a decision that you have to make on your own, and you want to just kind of look at the landscape of the problem and decide, like you did on the previous problems, if this were a plus, could I get either x or y to eliminate? And if this were a minus, could I get x or y to eliminate? And so I'm just going to kind of talk to myself and see what would happen if it were a plus. So if this were a plus, and so I'm going to imagine this was a plus. I'll draw it so we can see it. That would, and if I do the tap, tap, tap method, remember tap, 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 this would tell me that 6x plus negative 3x. And I know that the result of that is 3x. So that didn't eliminate, but it doesn't mean that it won't eliminate something. So now I'm going to try it with my y's. And so if I go tap, 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 the key on this one is knowing that this y term is actually negative. So when I say it, it's going to say negative 4y plus 4y. And if I just write that off to the side for a second, so negative 4y plus 4y. And so I know that that's going to add to 0y because a negative 4 plus 4 is 0. And then anything times 0 is 0. So these, by adding them, by choosing addition, would add to get 0, which means it's gone, which means it's eliminated. If, let's say, you had tried subtraction first for whatever reason, which is fine. Most people would try addition first, but if, let's say, you tried subtraction first, you would be doing 6 minus negative 3, which is 6 minus negative 3, keep, change opposite, so that would be 6 plus 3, which is 9. And this would say negative 4 minus 4, which you might be thinking, hey, wait a minute, isn't that 0? But let's just draw it out for a second. Negative 4 minus 4. I know there's y's, I'm just looking at the numbers. But then again, I would do keep, change opposite, and that would be negative 8. So it looked like minus might work, but it's actually going to be addition. So I'm going to go back to addition, and I'm going to add. And so now I'm going to complete this problem while using addition. So first I'll go back to the start again. So 6x plus negative 3x, that's going to be 3x, positive 3x, because the 6 is bigger. The negative 4y plus 4y cancels out. It's gone. So I could write 0, I guess. I could put plus 0, right? But plus 0 is going to just be the same as 3x. So I don't even really need to write it. Then I'm going to bring down my equal sign. And then I also don't want to forget to add these last pieces, 14 plus 1, right? So I'm adding x's, y's, and constants. And 14 plus 1 is 15. And I know that looks a little funny. I can't drag this over like I could in Notability. I'm going to explain everything right now. And so now I've got to get x by itself. And so it's being bothered by 3 by multiplication. So to undo it, I'm going to divide. And so then I would get x equals 5. And so you're probably super excited, right? You got x, you did something, you did some really good math. But remember that when we're going to give our answer, we're going to give our answer in XY format. So I've got my x, but I don't have my y. So I have two choices right now. I now know that x is 5, which I didn't know before. So I could either put it in the place of this x, or I could put it in the place of this x. It's not going to matter. It's going to give you the same answer no matter which one you do. I'm just going to put it in the top one. So that means instead of doing 6 times x, well, hey, wait a minute. X is 5, so let's do 6 times 5. Minus 4y equals 14. 6 times 5 is 30. Bring down my minus 4y equals 14. Now I'm going to do reverse PEMDAS to get y by itself. So y is being bothered by multiplication, but it's also being bothered by, in this case, I guess, subtraction. So reverse PEMDAS, I'm going to get rid of my 30 first, but since it's a positive 30, I'm going to subtract it from both sides, because remember, 30 minus 30 would be 0, so it would be gone. I'm going to draw my line. On this side, I'm going to do 14 minus 30. I could do keep, change opposite. You could also use a calculator. 30 is bigger and it's negative, so negative, that's going to be 16, because 30 minus 14 is 16, so negative 16. And when I bring this down, I don't want to forget that the 4 in front of the y is actually negative. And so now when I go to divide both sides, I'm going to divide, whoops, I don't know why that happened. I'm going to divide both sides by negative 4. And so when I divide both sides by negative 4, a negative divided by a negative is a positive, 16 divided by 4 is 4, and so now I know that y equals 4, and so my point of intersection is 5, 4. And so what that means too, just something to think about, that means that if I were to actually say, you could even do this too if you want to check it out, if you were to go on Desmos and to graph this equation, and to graph this equation, you would actually see that they would intersect at the point 5, 4. And back when we were in school, we learned how to graph these by hand. We were actually using either x and y intercepts or slope-intercept form to graph them. We're not practicing that skill right now, but that's a way that you could actually check your answers going forward, is you could bring these equations and type them into Desmos. So you would type 6x minus 4y equals 14, and then right below it you would type that. You would see 2 lines, and you would see the point of intersection. So it's a pretty cool way to check your work too. Okay, so on this next example, so again, I'm going to draw my line. I'm going to draw my circle, and in that circle, the only two things I could possibly put are addition or subtraction. So let's start with addition. Like I said, most people would test out addition first. And so let's see if addition would cause one of my variables to eliminate itself. So if I were going to add, I would have 6x plus 6x. That's 12x. It wouldn't eliminate. 7y plus 5y, that's 12y. It also wouldn't eliminate. So it looks like addition is not going to be the method that's going to cause elimination to happen. So let's try subtraction and see what happens. And so on this one, I've got 6x minus 6x. That's going to be 0. It's going to eliminate itself. And so I know that that's what I'm going to go with. So that, again, that decision, you've just kind of got to look at the whole problem, and you've got to decide, like we did with those first few problems that we were adding or subtracting, what's going to be the operation that can cause it to get to 0. And as long as you're saying it out loud, at some point you should get a 0. And if you don't, you're probably going to be like, I wonder why that happened. So let's finish this problem. So if I'm going to add, I've got, like I said, I've got 6x minus 6x, and so that's going to be 0x. So I don't even need to write it. 7y minus 5y, that's 2y. 8 minus 4, that's going to be 4. And so now my goal is to get the y by itself. It's being bothered by 2 by multiplication, so I'm going to divide, and then y equals 2. So it all kind of works out nicely right now. And we're purposely giving you problems that are coming out pretty good and have integer answers, so positive and negative, but not necessarily fractions or decimals right now. And so some people get really excited and they'll be like, oh, great, I'm done. I know what y equals. Yep, but remember, that's only half of your answer. We still need to find x. So I'm going to now take that y equals 2, and I could either plug it in here or I could plug it in here. I'm just going to do the top equation because it happens to come first. So I'm going to do 6x plus 7 times y, but oh wait, y is 2 equals 8. 7 times 2 is 14. I'm going to use reverse PEMDAS, which means I'm going to get rid of the 14 first. So I've got 6x equals 8 minus 14 is negative 6. You could either use a calculator, keep change opposite, but the 14 is bigger and it's negative. Divide both sides by 6. X equals negative 1, and so now I can fill the last half of my ordered pair, negative 1 comma 2. And so what this means is that if you were to graph these two lines, and you could even prove it by going to Desmos right now, if you were going to graph these two lines in Desmos, you would see that they would intersect at the point negative 1, 2. I hope that helped. Feel free to email again if not, and I can do some more clarifying, and I hope you're ready to have a great 3-day weekend. Enjoy!